So this is the tutorial for surface integral. So we have question 1b. So you have to evaluate, okay, the surface integral, okay, where the sigma is the portion of the hemisphere. So this is the hemisphere. Okay, so let's look at how we should solve the surface integral of scalar field. Okay, so if you have a surface, so you have to rewrite the equation of your surface so that the z will be located on the left hand side and the xy will be located at the right hand side. Okay, so this one is chosen when you choose to use the xy projection. Okay, so next one is we have to find the partial differentiation with respect to x for the z and with respect to y. So meaning that for the surface integral of scalar field, we have to transform, okay, the double integral into this format. So let's look at the solutions. So this is the surface integral of the questions, and this is the surface, okay, from the hemisphere, upper hemisphere. Okay, and this is the functions. Okay, so the function I will write it so that the z will be on the left hand side and the xy is at the right hand side. Okay, I choose this one because I decide to use the xy projections. Okay, next thing is I perform the partial differentiation with respect to x. Okay, so this is the differentiation with respect to x. I bring this one here and this one minus 1 become this, and this part remain, and inside here I differentiate with respect to x, so there is no y, there is no 4, I get negative 2x. Okay, so I rewrite it in this way and this represent my fx. As for my fy, okay, quite similar to the fx, okay, beside except that here will be negative 2y. Okay, so I will get this one for my fy. So I will put my fx square and also the fy square into here. Okay, and I can simplify them because here they are the same. Okay, so I can add both of them together. And this is what? This is actually from the questions because it is a z, right? Questions. Z is here. Okay, so we will remain this z, and the z can be rewrite as this function. So I have got this thing at the end, and here will become dA. There is no more dx. Okay, so here we will look at the xy projections. Okay, so for the hemisphere, when we look at the xy projection, we will see a sphere here. Okay, we will see a sphere. So the radius of the sphere is equivalent to 4. Sorry, the radius of the circle is equivalent to 2. Okay, is equivalent to 2. Okay, which means that now I can choose to use the polar coordinate or the cylindrical coordinate, okay, to solve these double integrations. Okay, so my dr will be from 0 to 2 and d theta will be from 0 up to 2 pi because it is a complete circle. Okay, so I insert it here for my dr and d theta. Since I decide to use the r and theta, I have to transform my x and y, okay, to r. So this one will become r square, and this one will become r, and this one will become r square here. Okay, so you have to be careful when you want to simplify this one. You can just combine this thing and this one, okay, because both of them they have the square root. Okay, if you don't know how to combine both of them, you can just make a simple assumption. For example, here is 4, here is 9. Okay, if you want to combine them, okay, it will become 36 here. So when you perform square root 36, you will get 6. Or if you do it separately, okay, this one is 2 and this one is 3, you will still get 6. So you just multiply them together, okay, in this way. You multiply them together, and the 1 I will write it in this way so that both of them can be combined. Okay, so here will be cancelled with this one, and now left this r squared plus 4 minus r squared, and these two things, they cancel each other. Okay, so at the end you left this thing, so you can press calculator when you want to integrate with respect to r. Okay, so you will get 8 pi at the end. Okay, next look at the exercise in page 181, exercise 4J. Okay, for exercise 4J, this is your 4J. This is your 4J. So now let sigma be the surface of this paraboloid, okay, that lies above the xy plane, oriented by an upward unit vector normal. So you have to find the flux of the vector field, this one. Okay, so when you need to find the flux, it means that you need to solve the surface integral with respect to vector field. Okay, vector field. So let's look at the solutions. Okay, so this is your paraboloid. Okay, information given by the questions, and you have the direction which is upward, and this is the vector field, and this is the surface integral that you have to solve. Okay, so you have the f, and now you have to find the n. Okay, since the question says that it is upward, so we will use the equation of upward. Okay, in the module, you can look at your module. Okay, so for upward, you are going to use this one. Okay, so this is fx and this is the fy. Okay, so first of all, what is f? So f is the equations of the paraboloid, okay, which is this one. So I need to perform del z del x and del z del y here. Okay, so for the del z del x or the fx, it is negative 2x, and for the fy is negative 2y. Okay, so when you insert to the equation of unit vector normal n, it becomes this way. So this thing I didn't insert it here because it will be cancelled out. Okay, when you want to transform from the dx to dA. Okay, so now let's look at this one. F given, dot product with the unit vector normal here, and now this thing cancel out. Okay, you get dA here. So for the dot product between the f and also the unit vector normal n, you just multiply according to their ijk component. Okay, so here you have 2x, it becomes 2x squared because the f here is the x, and for the j is the y, and for the k is the z. Okay, so I got the z and also the y square here. Okay, so for the dA, okay, I need to define the interval. So I have to look at the xy projections. So this is the paraboloid. When I refer from the z-axis or the xy projection, I see a circle. Okay, and the radius of the circle is equals to 1. Okay, so the 1 is obtained when I replace the z equals to 0. Okay, so for xy projection, we see this shape at the position z equals to 0. That's why I replace the z to be 0. Okay, so I get these functions. Okay, and it represents the radius of the circle is 1. So the dr will be from 0 to 1, d theta will be from 0 up to 2 pi. Okay, and this is from here. Okay, and the z, okay, I insert it with the equation of the paraboloid. Okay, so dA will become r dr d theta, and this thing you can transform it to become r 2r squared plus 1 minus the r squared. So you will get this one. So you can press calculator for these sections, and after that you can press calculator again when you want to integrate with respect to theta, and you will get this thing. You will get 3/2 pi.